All right, welcome Calculus Geniuses. We're going to take a look at our very first JTB, but this is our second practice problem. This one likely was just passed out in class for you, and we're going to run through this. We have the advantage on this that we should have a pretty good idea what this graph looks like. This graph, end model behavior, rises to the right, falls to the left. We can get some more information on that, but I'm going to treat it as if we do not know that at this time. All I know is, the question should be, does it just level off, go up? Does it continually go up, or does it go up, come down, go up? In which case, there's a max and a min. So let's get started. We're going to find our slope formula, our first derivative. F prime of x is 6x squared, as we all know, minus 6x plus 1. And we're interested in, so there's our y prime or our f prime x, as the case may be. We are interested in where that first derivative is equal to 0. So 6x squared minus 6x plus 1 equals 0. Are there factors of positive 7 that add up to be negative 6? You can try to 6 and 1. But we don't have 2 and 3. They're not going to work. We don't have, this is not factorable. Therefore, x equals opposite of b, positive 6, plus or minus square root of b squared, 36, minus 4, times a, 6, times c, 1, all on 2a, 12. So we get 6 plus or minus square root of 36 minus 24, 12, which is convenient. So we end up with 6 plus or minus 4 times 3, square root of 4, 2, square root of 3 on 12. So final answer, that would be 3 plus or minus square root of 3 on 6 when we divide the top and bottom by 2. So there are our zeros for the first derivative, which tells us that there are two places where the graph levels off. It looks like this. The graph looks like that. We have a maximum. We have a minimum. I'm going to go down to our sign chart. 3 plus square root of 3 on 6 would be to the right. And 3 minus square root of 3 on 6 would be to the left. That's where the slopes are 0. And let's say we did not know that the left one was a max and the right one was a min. Here's what we could do. Square root of 3, about 1.7. I'm going to say it's about 2. 3 plus about 2, 5 on 6, about 1. I'm going to pick a value bigger than 1. So for instance, 5. Now let's make it 10. Keep it simple. I'm going to pick 10, something that's out in this direction. Put 10 into my slope formula. I can do it right here. And we get 600 minus 60 plus 1, which is most definitely positive. The graph is eventually going up. Let's try 3 minus about 2. That's 1/6. Let's try something to the left. I could actually put in 0 here. 0, 0, 1. This is positive. As you'll see, I could put negative 10 in, something way to the left, and I get positive 600 plus 60. Very positive. And we expect these are negative. How would we check? We need a value between here and here. As it turns out, 0 is actually sneaky and over here. But take a look. This guy is 3/6 minus square root of 3 on 6. So it's 1/2 and a little bit left of there. This is 1/2 and a little bit right of there. Somewhere in the middle here is 1/2. Not somewhere in the middle. Actually, in the middle is 1/2. And if we put 1/2 in here, I promise you, we would get negative. So our graph goes up, levels off, goes down, levels off, goes up. Which tells us goes up, levels off, goes down. We have a maximum that's located at 3 minus square root of 3 on 6. The graph goes down, levels off, has slope of 0, then has positive slope, goes up. We must have a minimum at x equals 3 plus square root of 3 on 6. Now, what is the maximum there? We could either take this value, this x value, messy as it is, and put it in the original function to find the y value, we could perhaps go to our calculator, or we could just say, well, it's going to be whatever f of 3 minus square root of 3 on 6 is. Depending on, in this case, I said these y values will be stated as f of x. Okay, so that's the y value that associates to that point. And this, of course, would be f of 3 plus square root of 3 on 6. Just depends how it's asked. I may just ask for the location of the max, the x location of the maximum, x location of the minimum. I may say you can use your calculator and approximate these, or we can write it in f of x notation. Okay, what else do we know? The graph goes up, then down, then up. Or it increases, then decreases, then increases. So it is increasing from negative infinity until we get over to not 0 here, but there's our x value. It increases on the interval negative infinity to 3 minus square root of 3 on 6. And then in union with, it increases again later on. Slope is positive, increasing from 3 plus square root of 3 on 6 forevermore. Where does it decrease? On the inner interval. It decreases from 3 minus square root of 3 on 6 to 3 plus square root of 3 on 6. And you'll see the whole domain is covered. Negative infinity to here, here to there, and there to infinity. We got them all covered. And we are ready to take a look at second derivative. First derivative. So we need the f double prime, the second derivative of x would be the derivative 6x squared minus 6x plus 1. That derivative's derivative. Oh, well, that's not bad. 12x minus 6. When does it equal 0? When x equals 6 on 12, when x equals 1/2. That is not a coincidence that that 1/2 has been spoken about already. Halfway between here. Okay, so we've got 1/2. The second derivative is 12x minus 6. At 1/2, that derivative is 0. Something bigger than 1/2, like maybe 5, I get 60 minus 6 positives. Something smaller than 1/2, like negative 5, I get negative 66 negatives. The second derivative is all about the concavity, or the cupping as we refer to it. If the second derivative is negative, we are concave down. If the second derivative is positive, we are concave up. And therefore, we are concave up where the second derivative is positive, just starting on the other half side of 1/2. 1/2 to infinity. Concave down, negative infinity to 1/2. And all that leaves is the point of inflection. Inflection points occur when the concavity changes, and that concavity changes at 1/2. So that is 1/2. What's the y value? I would have to take 1/2, and that wouldn't be so bad. Put it in right here. F of 1/2. Not f prime, not f double prime, but f of 1/2. So that is all of our solutions. I know that's fast, but you can go back and take a look again. I'm going to go in here. Let's go ahead and clear this. Let's graph this guy and get some confirmation of this. So we'll come back up to our original. 2x to the third minus 3x squared. Whoops, I do that a lot. 2x to the third, step out of there, minus 3x squared plus x plus 3. And I think I've got this in a pretty good zoom area right now, so I'm going to go straight to graph. Oh yeah, that's a good look. Oh, we just barely go back down, but we can tell we go back down. So I'm going to go ahead and find that first maximum. Second calc maximum, that relative maximum, is somewhere between here and there. And let's see that maximum. I'm just going to jot this down over here to check solutions. Let's see, we have a maximum at 0.2113 and 3.0962. Second calc minimum, we get to the left of the minimum. About here is all I'm comfortable with, over to about there, and we get a minimum value of 0.7887 and 2.9038-ish. Let's take a look at those. So here's our maximum right here, 3 minus square root of 3 on 6. That's our maximum, as you can see. If I can get everything in one window. So I'm going to second, quit, clear, and let's find that right here. Let's go ahead and go 3 plus second square root 3 divided by 6 as a decimal is 0.7887. Is that our maximum or is that our minimum? That is our maximum. And our maximum, I've got that as our minimum here. Did I do that wrong when I went to the calculator? We can go back and check that in a minute. But I do like the fact that I hit that point. 3 plus. Okay. And then let's... Oh! That I put in 3 plus. Thank you. I heard somebody yell at me. I put in 3 plus. That should be our minimum value, 0.7886. Second entry, let's change that to minus like I intended. And there's our 0.2113. And I would suggest those points have to be correct then. And let's take a look. Here we can't be exactly sure, but let's take a look at that inflection point at 1/2. Second calc value, I'm going to put in 1/2 or 0.5, and that point comes, it does look sort of like it would be right there at where we quit cupping down, start cupping up. Maybe I can get a better look at that if I change my Ymin, Ymax. Just kind of playing around here. Let's go window -2 to 4, or 2 to 4. You'll see what I'm doing here. Kind of trying to accentuate that portion of the graph that might have the inflection point in. And now I go second calc value 1/2. And wow, that looks pretty good. That, you know, can we be certain that's where it is? No, but it looks pretty reasonable. You can zoom in, play around with that a little bit. Maybe go window 0 to 1. We're getting it really narrowed in. That's same as kind of zoom in, or we could zoom box it. And let's graph that one. So we start to see cupping down, cupping up. Second calc. I know this is a little bit overkill, but why not? Wow, I'm pretty convinced that's at least a reasonable answer. The Y value is 3 there, so we could get this at 1/2, 3. We also could have taken the 1/2 and put it back into the original function and find where that point is, and that would be pretty harmless to do on our calculator. So there you have it, JTBs. We are shooting for perfection, and we're not accepting anything less than that. Just the basics, and good luck. Let me know if I can help.